Today I'm going to be talking about using reflections. This is chapter 4, section 2. And it's very similar to translations, but we're just going to apply a different rule to this. So first off, it says graph triangle ABC with vertices 1, 3, 5, 2, 2, 1, and its image after a reflection in the given line. Now it says reflection in the x-axis, and if you did the warm-up, we figured out a reflection in the x-axis makes us take the opposite sign of y. So what we're going to do is just change the sign of all the y's but keep the value of the x's. So let's write down our pre-image, ABC. A is 1, 3, B is 5, 2, and C is 2, 1. And then we're going to apply our reflection in the x-axis. And we're going to keep the value of the x's but change the sign of the y. So A is going to be 1, negative 3, B is going to be 5, negative 2, and C is going to be 2, negative 1. And now we're going to graph as usual. So our pre-image is 1, 3 for A, 5, 2 for B, and 2, 1 for C. All right, and then we're going to do our image, which is 1, negative 3 for A, 5, negative 2 for B, and 2, negative 1 for C. And if you notice, if we put a mirror up on the x-axis, this is the mirror image, the reflection of that. So you can see how that works. Let's try another one of these, okay? This time we have a reflection in the y-axis. And when we have a reflection in the y-axis, we take the opposite sign of the x's. So let's write down our pre-image. A is 1, 3. B is 5, 2. And C is 2, 1. And now let's apply that. And we're not going to do anything to the y values. We're just changing the signs of the x's. So this is going to be a negative 1, 3, a negative 5, 2, and a negative 2, 1. And now let's graph and see what it looks like. It's for A, for B, and then for C. And let's do our image, negative 1, 3, negative 5, 2, and then negative 2, 1. If we take a look at this, it looks like we've held up a mirror on the y-axis, and that's our mirror image or our reflection in the y-axis. Now this one is a little different. It says graph triangle ABC with vertices 1, 3, 5, 2, 2, 1, and its image after reflection in the given line. And now we have a reflection in the line x equals 2, so we're no longer using an axis, but a line. And a line that is x equals any number is going to be a vertical line. So x equals 2 is going to be a vertical line at 2. The easiest way to do this one is just to graph it. We don't have to write any of the points down. So let's graph the pre-image. Let's do that in blue. So A is 1, 3. B is 5, 2. Oops, I did that one wrong. B is 5, 2. And C is 2, 1. Okay? And now what we're going to do is we're going to count how many units away is the point from the green line and reflect the same amount of units on the other side. Well, I noticed that A is 1 unit away, so I'm going to do 1 unit away on the other side for A. And we're going to do the same thing for B. B is 3 units away, so I'm going to do 3 units away from the green line on the other side. And C is on the line, so it stays. And now we have a reflection in the line x equals 2. Sometimes it will overlap, and that is okay. So let's try another one. This time we're doing a reflection in the line y equals -1. And anything that is y equals is going to be a horizontal line. So this one is going to be a horizontal line at -1. Then let's graph our pre-image in blue. We have 1, 3, 5, 2, and then 2, 1. And then we're going to count how many units that point is away from the green line and reflected on the other side. So A is 1, 2, 3, 4, so then I go down 4. C is 2 units, so I go on 2 on the other side, and B is 3 units. And now I have my reflection over the line y equals a -1. What we have next is graph triangle ABC with vertices 3, 2, 6, 3, 7, 1, and its image after the glide reflection. Now you've not heard that before, but it's very similar to our composition when we have more than one translation. A glide reflection is when we have the translation and then a reflection. So translation meaning move or glide the object around the graph, and then we reflect it. So it's a glide reflection. And we do this the same way as a composition. We do it in steps. So the first thing we need to do is write down the pre-image. 3, 2, 6, 3, and 7, 1. And then we're going to apply the translation first. So what we're going to do is we're going to subtract 12 to all the x's, but then keep y. Don't do anything to y. So 3 minus 12 is a -9, 2. 6 minus 12 is a -6, 3. And then 7 minus 12 is a -5, 1. So we've now applied our translation. Next, we're going to apply our reflection in the x-axis. And remember, when we have a reflection in the x-axis, we're going to take the opposite sign of y. And we don't do anything to the x's. So the x's stay the same, but we change the sign of the y. So it's a -9, -2, -6, -3, -5, -1. And now I'm going to graph the pre-image and then the image. Six, 3 for B. And then 7, 1 for C. And let's graph the image. -9, -2 for A. -6, -3 for B. And -5, -1 for C. And if you notice, the blue got shifted over and then flipped over the x-axis. So we now have our glide reflection graphed. Next, I'm going to talk about lines of symmetry. And this one says, determine the number of lines of symmetry for the figure. Now, line of symmetry is if we draw a line through it and fold the figure at that line. If we fold it, it will be the same on top of each other. So it looks exactly the same. So line of symmetry for the first one, we can fold this straight up and down, and if we put those pieces together, they'll line up exactly. So that's one line of symmetry, but we also can fold it in half like that, and it'll still be the same. So that's 2. We can go diagonal, which is 3. We can do another diagonal, which is 4. And we actually can go through these vertices diagonally. So that's a 5, and then the other vertices, 6. So this one has 6 lines of symmetry. For number 2, we can fold it straight up and down in half, and then all the way across. But we can't fold it diagonally because the points won't line up, so we only have 2 lines of symmetry for this one. Next up, we can go all the way across. That's only one we can do, so that's one line of symmetry. For number 4, we can go up and down and all the way across. We cannot do diagonal because once again, those points will not line up. So we have 2 lines of symmetry for this one. All right, for number 5, we can fold it straight up and down. That's 1. We cannot fold it through the half because it won't meet up. But we actually, if you notice, it's going through a vertex and the middle of a side. And we can do that for each vertex on this figure. So that's 1. This is 2. This is 3. This is 4. And then we have 5 lines of symmetry. And our very last one, all we can do is fold it straight up and down, so we have 1 line of symmetry for that one.